What is a DC-DC converter? It's a power electronic device which is used to step up or step down a voltage. In some cases, it is even used to maintain a voltage based on variability of the input voltage. So it's represented by similar symbol. There are different variants of this. The two constant lines represents a constant steady input and output. There are dashed variants as well. So a double dash represents some sort of pulsation or variability in the input or output source, often used for rectified AC that has not been fully smoothened. There's a triple dash variant as well, which is less common use but denotes a highly regulated or filtered DC voltage source. So in this case, you can see the input as well as the output of a DC-DC converter is a DC power. So it's not converting DC to AC, it's only stepping up, stepping down, or maintaining the voltage. There are three different types of DC-DC converters broadly. There are other variants as well, but these are the commonly used variants. The first one is buck DC-DC converter. The function of this converter is to step down the voltage. Next is boost. As the name suggests, it is responsible for stepping up the output voltage. So the output voltage is higher than the input voltage. And then we have buck boost, which is a combination of above two, which can perform both stepping up as well as stepping down the voltage. Now, the question would be, how is this useful in an electric vehicle? So let's first understand what are the different loads which the high voltage battery interacts with and in which application one of these can be used. So this slide, this schematic shows usage of a high voltage battery. So a high voltage battery is responsible to power not only the high voltage loads, which consist of traction motor, compressor, but it also is responsible to power the low voltage loads indirectly. So the high voltage battery will be responsible for charging the low voltage battery in case it's over discharging based on the auxiliary load. Now the low voltage load comprises of interior lightings, headlights, infotainment system, power window, power steering, etc. So there are different applications as you can see from this slide. A high voltage battery interacts with the low voltage system. So there is a need of stepping down the voltage. It also interacts with high voltage loads, which may require stepping up the voltage. So the question is when to use each of these types of DC-DC converters based on the applications we have discussed so far. Let's break it down. When it comes to high voltage loads, battery might be insufficient to provide the required voltage. In such scenarios, we might have to step up the voltage where a boost converter can be used. On the other hand, when the high voltage system interacts with the low voltage loads, there's a need to step down the voltage to, let's say, 12 volts or 24 volts. And in such scenarios, a buck converter can be used. Additionally, a battery typically has a tendency of decreasing voltage with over time. So as the state of charge of the battery goes down, the voltage also goes down. So this might lead to a difference in the initial as well as the final voltage. Now, a compressor might be suitable or compatible in a given range of voltage. Initially, the voltage might be higher, so there's a need to step down the voltage. And maybe finally, over time, as the state of charge changes, there might be a need to increase the voltage. So to maintain the voltage, a combination of the above two, also known as a buck boost converter, can be used. A buck boost type converter based approach helps you mitigate the impact of low SOC on the operation of critical vehicle systems such as air conditioning system, ensuring consistent performance and passenger comfort regardless of the battery state of charge. So this is how a DC-DC converter works, and hence, based on the discussed points, all these three different variants of DC-DC converters are combinedly used in an electric vehicle.